It's 3 o'clock, so I would like to welcome everybody to this Meet the Oracle Masters online series session. It's the third one we present as Qualogy, and I'm very happy to welcome Stephen Feuerstein. Stephen, nice to have you here. How are you?
Doing quite well, thank you.
All right, great. Before we start, few small things. As I told you, this is the third presentation we offer. We decided to video and record all the sessions. So at our website, currently already, the first session of Connor McDonald is now available. So if you missed that and you want to see it, and I can recommend it, go to the website and take a look. Same goes for the second session of Maria Colgan. She will be there pretty soon on our website. But for now, without further ado, I would like to introduce to you Stephen Feuerstein, and wish you a lot of pleasure and a lot of knowledge sharing during the coming hour. Thank you.
Thanks very much. And if you could just stop the share for a moment, I'll turn the share back on when I, thank you.
All right, there we go.
Hello, everybody. So my name is Stephen Feuerstein. I'm a developer advocate and lead a team of developer advocates at Oracle Corporation. I'm really pleased to do this presentation. I am very pleased to see remotely my Dutch friends. I have I must confess, a sweet spot in my heart, in my head, for the Netherlands. It was my first international trip for my Oracle work. A long time ago, I went to the European Oracle User Group to do a presentation. It was in the Netherlands, and love the country, love the people. I've been back many times. I may not be back again given the current circumstances and my tremendous aversion to travel even before the pandemic, but love the Netherlands. So it's good to be back in any way that I can. So what I'm going to do today is spend about an hour talking about some of the newer features of Oracle PL/SQL. Before I do that, I just want to encourage all of you, hopefully you're all healthy and safe. Stay safe, be careful. Obviously things are opening back up, but please, when you go outside, when you're near other people, wear a mask. I know it's a controversial topic in the United States for some, but it shouldn't be. Take care of yourselves, do everything you can to make the earth a better place for both our human inhabitants and the non-humans as well. Okay. So I'm going to be talking about newer stuff in PL/SQL. PL/SQL has been around for a long time. First came out in 1991. And of course, it's very stable. I wrote a book back in 1994, and most of the pages of that book are still in the latest edition because PL/SQL doesn't change, it adds on. Of course, over the years, as we've completed more and more of the functionality of PL/SQL, the add-ons get to be a little bit more niche oriented. So I'm going to talk about a lot of different topics today. Some of them you might say, I don't care about that. Some of them you might say, wow, that's fantastic. I've been waiting all my life for that. That'd be great. The objective of this presentation is not to go into a deep training on any of these topics, but to give you a sense of what's there, what you might not have been aware of if you're not keeping up with the latest changes in the language, and hopefully give you some ideas about how you can improve your developing further on. In terms of getting in touch with me and learning from me ongoing, shouldn't be hard to find me online. I'm on Twitter, SF_on_PL/SQL. I've got the Practically Perfect PL/SQL YouTube channel, and my extremely long blog post named Stephen Feuerstein on PL/SQL. So check it out. Now, what I'm going to be doing today is talking about PL/SQL technology, and it's easy to get information about PL/SQL and SQL all over the place. We offer 3 community websites that hopefully you're all familiar with and will take advantage of. The first is Ask Tom. Hopefully you all know about that great Q&A site, which is now being answered by 2 members of my team, Connor McDonald and Chris Saxon. In addition, we have the Office Hours program, in which we have monthly dozens of sessions with experts within and outside of Oracle. Oracle DevGym offers quizzes, workouts, and classes on lots of Oracle technology. And Oracle Live SQL provides 24/7 access to the latest version of Oracle database with a code library. And I'm going to be using Live SQL today to show you a lot of the scripts that I've written and others to demonstrate the features of PL/SQL. And hopefully you'll use it as well. And of course, Can't talk about Oracle technology today without mentioning the Oracle Cloud and the very wonderful, always free Oracle Cloud tier. So you sign up for your 30-day trial. When it's over, if you don't sign up for a paid service, you'll always have access to free services, 2 autonomous databases, 2 VMs, lots of storage, load balancer, and Application Express for your application development needs, SQL Developer on the web. So at this point, there's no excuse to not use Oracle database in a variety of circumstances. And specifically, my suggestion is, assuming you already know how to use Oracle database, to think about how you might use the always free tier to provide services to organizations, friends in your community who might not be tech savvy, who might be able to use this technology, and you can help them do it. Now, in terms of this presentation and all the code, go to slideshare.net, search for PL SQL new stuff. You can download this presentation or a slight variation of it from the past. You can also go to the bit.ly that you see on the page here, SF demo files, to download a zip file with hundreds and hundreds of scripts, including those referenced in this presentation. Or, best of all, go to livesql.oracle.com, search out keywords, you'll see them in the presentation, and then you can actually play around with the scripts online. So, this is the stuff I'm going to cover today. I'm not going to talk about it on this slide. In fact, Connor McDonald recommends that you never have an agenda slide in your slides at all. But I figure when you come back later, you'll see the list and you can dive in from there. So we're going to cover this stuff. Let's start with one of the newest features in PL SQL and one of my favorites for sure. And these are qualified expressions or constructors for associative arrays and records. Now, if any of you have been using the object type elements, the object-oriented elements of PL SQL and Oracle database in the past, you'll be familiar with the idea of constructors. So each type has a function of the same name. You call that function, you pass it the elements for the attributes, and it returns an object type instance. Very convenient. But that was not available for associative arrays, in other words, the index by collections, and also our own user-defined records in the past. Now they are. So let's just jump right over to LiveSQL to check this out. So LiveSQL, I'm going to search for qualified. You can see I've done this before. And my session has expired. Of course it has. Lovely. That's okay. I can search without being signed in. So qualified, I find my matches. Let's start off with qualified expressions for records. You can come to the site. You can do the same searching. Here's the script. You can log in and run it. I'm just going to scroll through it so you can see it. I'll even make it bigger. So here's the wonderful world in 18C. So right now, when I declare a record of my own type, it comes with this qualified expression, but you can think of it as a constructor function. There's the function call. I pass it the elements, and it gives me the record back. So right in line, I can do this instead of assigning individual values line by line. And so that's really all there is to it. No problem. And you can also use name notation. So you can put them in any order you want. And essentially, it just gives you a nice, convenient, compact way to both initialize variables, to pass them as parameters, and so on. So, and by the way, even if they're the same type, they have the same structure, but they're different names, it is not going to work. Okay, so that's qualified constructors for records. Let's check out qualified expressions, not qualified constructors, for associative arrays. So in the bad old days, and you might still be in them, it's true if you're not an 18C yet, if I declare my index by collection or associative array, and I want to assign values to them, I have to do it line by line, element by element. Yuck. Not terrible, but not the greatest. So now I simply provide inline. There's the name of that qualified expression, pass the values, and I have to always use name notation. With records, it's optional, but with arrays, it's always name notation. You can do them out of order, doesn't matter. And just in case anybody was wondering, let's go scroll down to the bottom. It even works with the string indexed arrays. So with associative arrays, one of the unique features of this compared to nested tables and V-arrays is that you can also do string indexing. Lots of interesting applications of it. But in this case, I simply can specify those values right in line. And also, you can use expressions. They don't have to be literals. So lots of flexibility. and a much more compact way of writing your code. And of course, it's not just for declaring variables with initial values, but you can pass these as parameters. You can use them as default values on parameters, all that sort of thing. So hopefully you'll agree that's a really nice feature from the standpoint of user productivity and readability. Moving on. So this is a feature, PL Scope, that was added actually back in 11G, but it's been greatly upgraded in Oracle 12c. And it's an expansion around code analysis over what we would previously have used, which are essentially the dependency views. So the classic question that we often have in our database code is, well, it's all in the database. How do they connect? What is dependent on other elements? And how do I manage that data, manage that code? So the all dependency view will allow you to say that this table, or sorry, this package depends on this table or these 16 tables. But the level of detail below that was very limited. You couldn't say, well, what columns in the table and what kind of operations am I performing on the table? None of that was visible before. But with PL Scope, all of that is visible for you. And the really wonderful thing is that as of 12c, it not only analyzes the PL SQL code in your application, but the SQL statements inside your PL SQL code. So the basic idea behind PL Scope is that when you turn it on, and that's with an alter session statement or even alter object statement to collect identifier information, then when your code is compiled, the PL SQL engine grabs all the information about all the named elements in your code, all the identifiers. So where is that variable being used and how is it being used? Which subprogram is being used and where and how? In addition, SQL statements. So you can use, so you gather this data, it's put into the set of views, and then you write queries against those views to get your information. And you can answer questions like, where is a variable assigned a value in a program? So think about it. If I'm in a text editor, I can say, well, I need to, there's a problem with my variable L underscore statement. So I search for L underscore statement and I can find it in 25 different procedures perhaps. Sometimes it's being populated, sometimes it's being read, sometimes it's being displayed. But you can say things like, where is my variable assigned a value? So the variable's been set to null. How did that happen? And you can, of course, do debug, you can do tracing, but with this thing, you can actually identify the 16 places in your code where you have a select into, or it's an out parameter, or there's a direct assignment, et cetera, et cetera. Which subprograms call another program? So down to subprogram information, you can do the tracing of calls. My favorite, for sure, is which SQL statements appear more than once in my application. I'll come back to that and show you in Live SQL. And now you can do full CRUD analysis. You can say, which of my subprograms do inserts on a given table or updates on a given table? And it will give you that kind of information. Let's take a look. So now I'll search for PL Scope. You find lots of different examples here. I'm going to dive right into find duplicate SQL statements because this is one of my favorites. So as you're probably aware, you can write SQL in PL SQL quite easily. And the problem with that is it's too easy and we tend to take it for granted. So we, in many, many shops, as I've seen over the years, as I've traveled around and talked to organizations, I'll often ask, who has coding standards for their applications? And most people will raise their hands. We have some sort of standards. How many of you have coding standards that have any rules about when, where, and how to write SQL statements? And then pretty much all the hands go down. Like, why would you do that? It's so easy to do, you just do it. And that's the problem. So it's very possible that the same SQL statement will appear in multiple places throughout your code. Now, that might not be a really big problem. It might not be a performance issue. There might be simple primary key-driven lookups like this. But if you ever do need to optimize it, if you ever do need to maintain that code or enhance it, you have to find all the instances where it occurs. Furthermore, finding matches could be very difficult. For example, this statement and this statement look quite different. They're physically different. But it turns out that one of the other beautiful things about writing SQL in PL SQL is that post-compilation, these two statements are the same statement, literally physically the same statement. So the PL SQL compiler canonicalizes or standardizes the format of static SQL statements when it compiles that code. So by the time these two procedures are compiled, those SQL statements are a single line of text, all the keywords are uppercased, all the extra white space is gone. They are physically the same. And the nice thing about that is that this is an automatic optimization feature of PL SQL so that the cursor will be shared. When each of these procedures are called, it will be recognized as the same physical statement by the engine, the database engine, and will not open another cursor. That's a reason you should always put your SQL inside PL/SQL code. But again, looks really different here. Here's the really cool thing though. Now, because of the canonicalization and because of PL scope, we can actually find out where this same query, even if it differs physically, appears in my code. So I've compiled these two programs. You can see in my user statements table, so this is the table that stores the information about SQL statements from PL scope. You can see here the canonicalization. They are literally, physically exactly the same. But they have a different signature because they appear in different places. They have the same SQL ID. So now it's quite easy. Here's a SQL statement I can run to identify all SQL statements that appear in more than one place. Wow. And I can add joining to source and so forth, and I can actually find out the objects, and I can look up the source code and so on and so forth. So this is one relatively simple example of using PL scope that can be an enormous benefit to you in terms of analyzing code, making it easier to maintain. Now, PL scope is also an enormous topic to cover. We could take a look at a lot more of the examples here, but of course I don't have all that much time. PL scope examples, the top level one, is probably your best starting point. It shows you how to turn on the gathering of identifier information. And then it runs through some examples of packages and what kind of data you can get out of it. Here's a query against the PL scope table that gives me information about my identifiers and the hierarchy. I can find out things like naming convention violations. If I can define my naming convention in SQL, I can verify that naming convention in my code with PL scope. So lots of opportunities to explore. To make it easier for you, I've created a blog post called the PL scope Resource Center. Just search for that keyword. And you'll find links to the documentation and links also to other scripts, other utilities from the community. In particular, Philip Salvesberg has created a great utility for PL scope and integration into SQL Developer. So check out his PL scope utils. It's way more sophisticated than anything I've done, that's for sure. So do check out PL scope. It can be a challenge to write the queries. That's why we give you lots of examples on Live SQL, the documentation, and Philippe as well has done a great job there. But it can make an enormous difference in your ability to analyze and maintain your PL SQL code. Moving on. So one of the nice features that was added in 12.1 is the accessible by clause. And the accessible by clause gives you additional control over who can access the code or what other programs can access your programs. Now, obviously, there's the grant execute. So unless you're connected to the schema that owns the code, you cannot see or run that code unless you're granted execute onto that package or that subprogram, procedure or function. But within that schema, or if you have access to that code base, then it's wide open. You can access anything you want. And accessible by gives you the ability of pushing the concept of privacy into package subprograms and create an approval list for program units that can invoke a package's subprograms. Now, probably the clearest use case for this is, well, think about it. You've been writing code for a long time. I've been writing PL SQL code since 1991, almost nonstop. I've got some really big program units. So for example, I build the backend code and maintain the backend code for the dev gym, classes, quizzes, workouts, etc., managing the office hours program. I've got some packages that have tens of thousands of lines in them. And what I found, for example, my class manager package had gotten so big and my functionality for class support had gotten so expanded that I really needed to break it up. So I had a single class manager package. Now I have a class manager package, a class email package, and a class question package. So 3 different packages that all used to be in one. So this is a very common process. I've got this very big package. It's hard to manage, hard to maintain, hard to allow multiple people to work in it at the same time. How can I make it easier? Break it apart. The problem with that break apart process can often be that the part that you want to break out, so I've got one package body, I'm going to break it up into 3 package bodies and 3 package specifications. But one of those packages, or maybe all those other new sub packages, really only should be called from the original package. In other words, they're not really public programs. They're just broken out for management purposes. But once I put it into its own package with its own specification, anybody with execute authority on that package or connected to that schema can get at it. So now what you can do is create what you essentially can call as a private package. So this code used to be inside my main public package. I've broken it out, but I only want the public package to be able to use it. And I can simply now say accessible by that package. And it can be a list of elements as well. And in 12.2, you can even specify subprograms. So this way, you can create your much easier to manage code base. You can allow multiple people to work in those different packages at the same time, but you can control access to that code. Let's go over to Live SQL and take a look. Search for accessible. All right, so here's the idea. I created my code as accessible by public package. My public package body is now just simply a redirect to my private code. This is the extreme. There's literally nothing left in my public package body. It's all been pushed out. And then if I try to use it from a source that is not allowed to, so notice I can run it through my public package, but if I try to go directly to the private package, I have insufficient privileges to access it. So you get that additional level of control. So more PL/SQL-only data types cross the PL/SQL-to-SQL interface. So I'm sure you know that one of the nice things about SQL, about PL/SQL and SQL is not only that you can write native static SQL just so easily, so transparently. You can also do dynamic SQL very easily with execute immediate, and DBMS SQL as well, but it's very rare that you'd find a reason to do that. So dynamic SQL has been great inside the PL/SQL environment, but you could only bind in data types that were known to SQL. So for example, you couldn't bind a Boolean. If you had a user-defined record, or if you have a user-defined collection, you couldn't bind those as well. So now as of 12c, that's very much opened up. And now you can bind records and associative arrays. You can even bind Booleans. Not that you can bind them into SQL statements, because there's still no Boolean in SQL, but you can bind them into your dynamic PL/SQL. You can also use the table operator with associative arrays. Let's go to Live SQL and check out the binding options. So here's a function with a Boolean parameter. And in the old days, you would not be able to reference that Boolean inside your SQL. But notice now, right inside my SQL statement, I can call that function and I can pass a Boolean value. Now, this is not a Boolean in SQL, it's within the PL/SQL context in the SQL statement, but that was not possible before. I can also do binding of Boolean values in dynamic SQL. And let's go down and take a look at arrays. So here's my collection. I've got a record. I've got a collection of records. And now I can look, first of all, with the table operator, I can actually say, run a query against my associative array. So prior to 12.1, you can only use the table operator with collections of type nested tables and v-arrays, the SQL recognized types. But as long as your type is defined at the package level, it's known to the SQL engine. And this, we knew that because it was supported for pipeline table functions for a number of years. But now I can actually do an open select from table. So that gives us a lot more flexibility around working with that data in associative arrays. All right, so there's my table with associative arrays. And we can also bind user-defined record types. So here's a procedure that takes in individual values, passes back a record. No problem. This can now be done. Here's dynamic SQL, binding an entire record. So lots more flexibility for you. Again, these are pretty much there. You could think of them as small things, small rough edges that we're smoothing out of the language. But as a developer who works with PL/SQL day by day by day, if you're like me, it makes an enormous difference. There's just one less impediment, one less blockage where you say, I sure wish you could do that. So optimizing function execution in SQL. So suppose you've written your own function and you want to call it inside SQL. And this has been available in PL/SQL for decades. And it's a fantastic feature because it allows you to essentially extend the SQL language with your own code, which is great. There's a problem there though. And the problem is that there's a context switch that goes on between SQL and PL/SQL. So inside my SQL statement, when I call a PL/SQL function, Every time that function is going to be invoked, the SQL engine stops, transfers control over to the PL SQL engine, passing the function call with the bind values, the variable values for the arguments. The function is then executed and the value passed back. And that context switch is the source of performance degradation, which is why, for example, we have the for and bulk collect features, bulk processing in PL SQL, to minimize the number of context switches. The idea with these two features, the with clause for functions and the UDF pragma, is that they cut down on the cost of a context switch. Now, I didn't think ahead far enough here. I'm going to start up SQL Developer. I can't demonstrate these things to you in Live SQL. The with clause is not yet supported in terms of the actually parsing syntax on the Live SQL site. And so what I'm going to do is show it to you inside SQL Developer. That'll start up in just a second. But the basic idea is that the with function is just like the common table expression or with subselect. You can actually define a function directly inside your SQL statement, which is pretty interesting. The UDF pragma is a bit different. In that, what you're saying to yourself is this function is going to be almost always called from within SQL. So I might use it occasionally or even never in a PL SQL block directly. It's always going to be inside SQL. So when I include the pragma UDF, just move this out of the way while it's getting started up. Actually, I don't need to do that, I guess. I'll just open up a file for you. Okay, let's do that again. Yeah, let's see if I can make it a little bit bigger for you. Sorry, should have been a little bit better prepared. Whoops, that wasn't right. Font 24, much better. Okay, so now what you see here is a function called UDF function. I have pragma UDF. So it's a declarative statement that is basically telling the compiler, hey, I'm going to be calling this from within SQL as a user-defined function. And what that tells the compiler is that it can do some things at compile time that would normally wait to do at runtime, basically matching up the data types, because there are differences between SQL and PL SQL under the covers that we don't necessarily see. As much as possible, that's done at compile time. So the runtime context switch, it's still there, but it's a reduced cost. In case you're wondering, so that's the pragma UDF. You just put the pragma in your code and let the compiler take care of things from there. This is an example of using conditional compilation. So this is basically allowing me to specify flags in my code that I can use to turn on and off different areas of functionality, allowing me to test different scenarios differently, allows me to basically compile different versions of my code depending on the version and other things. So conditional compilation, a whole nother topic, but that's the basic idea behind the UDF function. The UDF pragma. Note also that depending on the data types of the parameters coming in, it will have more and less effect on performance. So it's quite possible that you'll add this pragma to a user-defined function and you will not see that much of a benefit today. I would still argue that you should put it there. If you know the function is only going to be called in SQL or almost always called in SQL, put the pragma there, because in future versions, in 19 and 21 and 21, whatever else, as the PL SQL engine gets smarter and smarter and extends out its support, it'll be able to utilize the information you're giving it. That's another reason why you might want to also consider declaring your functions as deterministic when they are. I won't get into all the details of this, but it can have deterministic, can have an impact on performance, but more importantly, you're giving the compiler more information about your function. My function has no side effects. The return value is only based on the value coming in, and this is information the compiler can use to help you more effectively. And let's see if I can find a with example. With function 12c, there we go. So now inside your SQL statements, you can literally declare a function call, and then you can call that function inside your select list, inside the where clause, etc. Now the use case for this, I think, is going to be fairly narrow compared to identifying opportunities for UDF. But the advantage here is that if you have a simple formula that you repeat multiple places in your SQL statement, you can consolidate that into a function call, not repeat the formula, and reduce the cost of the context switch compared to putting the formula into a stored program unit. It also might be such a trivial computation that it just doesn't make sense to worry about putting it in a package. The other advantage is if you have a read-only database. So for example, it's a backup database, and you can't create functions or packages in that base. You can simply add your code into the with clause. You can even create procedures here that are then called by the function, but you can't call the procedure in your select statement. Okay. Util call stat package. So hopefully you're all aware of several different functions that have been around for a long time in the DBMS utility package. One is called format call stack that answers the question, how did I get here? A called B called C called D, or Q called R called D. Format error stack, which is what is the error message or stack, which is quite similar but not exactly the same as the SQL error message function, SQL-ERRM. And most importantly of all, added in 10G release 2, format error backtrace. What was the line on which my error was raised? Something that we didn't have for many years in PL SQL, but now you can actually trace back to the line of code in which the error was originally raised. So these are really great functions. And in fact, Oracle recommends that you not use SQL error message. Just use format error stack as the way of getting the error message. But then things got even better. So in 12c, a new package is added called util call stack. And the idea behind the util call stack package is that we give you the ability to get into the stacks or the traces that we had previously returned as a string. So format underscore means we formatted this data for you, here it is. Util call stack basically comes before that formatting process and gives you access to the individual elements in the stack. Let's go over to SQL. Now I have a confession to make. I think this package is nice to have, but I have a feeling that very few of you will ever use it, that you'll find that calling these functions format call stack, backtrace, and format error stack are going to be good enough for you. But in case you do want to start to explore util call stack, come and check out these scripts. And so basically we now have the ability to get all this information as individual lines of data, not as one big string. And there are some advantages. So for example, with using format call stack, what you don't get is the subprogram information. So inside util call stack, you can actually say if it's package.procedure.nested procedure.nested function, so they're all nested within. They're not even public programs in the package. You can say, give me the concatenated subprogram call, and it will put them all together for you. And you can see all that information. And there's lots and lots of details in the API in terms of getting the individual units, the individual lines, the individual elements in a point in the stack. So if you want that level of granularity, you can get it. Like I said, I'd say for most of us on a day-to-day basis of our PL SQL code, you're probably not going to get much use out of it. Okay, so some more ease of use functionality and improving maintenance of code. Static expressions in place of literal. So one of the things that has always bothered me is I'm typing my code and I need to declare a variable. It's a varchar2, and then I have to stop. What number should I put in there? Should I put in 10? Should I put in 50? Yes, I should anchor it to a column in a table if I can, but it's not always relevant. All right, I'm just going to make it varchar2 32767 because it's never going to get bigger than that. Well, you've probably been around long enough. It doesn't take long to know that if you ever say to yourself, it's never going to do X, or it's always going to do Y, chances are you're wrong and you're sticking a bug in your code right there. It'd be really nice not to hard code these things. Now you might say, but that's the biggest a varchar2 can ever be. So what's the harm? Well, number one, it might not be the biggest it can ever be. We might extend that. Maybe at some point clobs and varchar2s will be the same. In addition, if you did say, look, the rule in our organization is we're going to make everything varchar2 32767 just in case. Number one, it makes your code look funny because you'll be declaring everything as a really big string and people will say, but it doesn't get that big. And number two, some people would say, and it will take a lot more memory. It will not take more memory. It is dynamically allocated memory. In fact, varchar2 32767 variables take up less memory than varchar2 400 variables. I won't get into the details, it's in the documentation, but it's actually true. None of this should really make a difference for you in general, but you still come down to this problem of how do I declare things? So now, as of 12c, you can actually use static expressions instead of literals. Back to live SQL I go. static expressions. So first of all, what the heck is a static expression? Well, first of all, if you ever hear the word static versus a dynamic, what should immediately come to mind is compile time versus runtime. So a static expression is an expression that can be evaluated at compile time and will not change at runtime. Obviously, a literal is a static expression. 32,767 times 16 is a static expression. Sysdate is not a static expression because obviously it changes every time you access it. So if you define static expressions in your code, you can actually use those to do your declarations. Now, this is kind of silly. I'm declaring it 32,767. Then I'm declaring a subtype over it. But the point is that I can now in my code simply declare my big strings as this. And I can hide that data type away. And I don't even have to hard code it here. In addition, there are some predefined, did I put it on the page here? Yes. There's also an aura max name length predefined constant that you can use to declare your variables. So in general, going forward, you never have to hard code anywhere in your code the maximum length of an identifier because we provide this value for you, and it could change over time. Right, so now things have gotten a little bit more relaxed. You can avoid hard codings where you had to hard code before. Nice. And this kind of links up to goodbye tiny name lengths. So prior to 12c, your identifiers could only be of length 30. And on the one hand, what a pain in the neck that was, because if you had a table, you had a prefix for the application, you had your table name, and it got just over to 30 characters, 31, 32, then you had to start to get into how do I truncate it and how do I still make it understandable? And you started to feel like, wow, MS-DOS and 8-character file names, why do we still have to deal with this? So we dealt with it. It wasn't easy. I mean, it's easy conceptually to extend the size of a variable to 128. Pragmatically, given, for example, all of our data dictionary reviews, it was a big job. I have been told they don't let me near the code. Believe me, they don't let me near the kernel code of Oracle database. So I don't know for sure, but it's what I've heard. Anyway, the bottom line now is you can create names that go up to 128 characters, 128 bytes, which is fantastic. But that doesn't mean that you should create identifiers that look like this. No, really bad idea. The basic use case for this expansion is, first of all, if you're migrating from other databases and other languages to Oracle, and they allowed much larger names, which many other languages have for years, you no longer have to go through any sort of changing of the names. They can stay in place. Better support for multi-byte character sets. And for me on a day-to-day basis, the biggest impact of this is if I have a name that just goes over 30, goes to 32, 35, I no longer have to make a decision about truncation. I just say, we're good. It doesn't even bother me anymore. So, nice stuff. Goodbye tiny SQL var-char2s. So for many years, there was an impedance, a difference between PL SQL and SQL. You could have var-char2s that go up to 32K in PL SQL, but only 4,000 in the database. So you'd have to switch to CLOBs for pretty small strings. I mean, 10,000 bytes is not tiny, but it's also not massive given these days, and document databases and so on. So now, once your database administrator sets the max string size parameter to extend it, and this is a one-way change only. Once it's done, you don't go back. But once that change is made, then var-char2s and nvar-char2s can be extended to 32K as well. So minimize the need for CLOBs, stay within the var-char2 set. Though as many of you may be aware as well, the difference between var-char2 and CLOBs have decreased over time. So years ago, you had to use DBMS lob to do almost any kind of operation on a CLOB, but now you can do substring, in-string, replace directly on CLOBs. Okay, so in 12c, we also added the ability to document deprecation of code. And this makes a lot of sense because, well, we've been building code for a long time inside Oracle, outside of Oracle, and over time, code gets deprecated. We're no longer using this thing. We want to use something new, but there are still places in the code that might use it, so we can't just get rid of it. So now inside 12c, you can actually document that a piece of code is deprecated. Now, it's just basically comments in your code. Well, it's structured comments in your code. They don't do anything per se, but you can take advantage of compile time warnings to identify where deprecated code is being used. And also at some point actually turn off or make it impossible to compile units that use deprecated code. Let's take a look. So notice I'm turning warnings on. Hopefully you're all familiar with compile time warnings. This is a feature that will give you feedback on your code when it's compiled. So in addition to errors, in other words, well, your code won't compile because you left out a semicolon, it'll also say your code compiled, but here are some areas that we think you could do better on. You can improve your code around. And then what I'm going to do is mark, here's the new feature in 12c. Compile time warnings have been around since Oracle 10G. But what I'm going to do is mark this package as deprecated. And notice now when I compile this code, it gives me feedback because warning is turned on. It said entity package is deprecated. Okay, but now I'm going to actually create my package body, and I'm going to try using the deprecated unit. And notice I now get a warning saying reference to a deprecated entity. You use something that's deprecated. That's not a good idea. So what you could do, so you can put pragmas in your code, your deprecation pragmas, and basically, again, give additional documentation in your code base in a structured way about, I'm using it in SQL-Only, this code should not be used anymore. But then what you can also say is, you know what, we're done with, we posted deprecations for a year now. What we're going to do is turn those deprecations into errors, those warnings into errors. So I'm going to specify 6020. I'm going to specify all of them right now, all the deprecation-related warnings as errors. And then, well, first of all, you don't want to do this because when you try to compile the package that's deprecated, it won't even compile. What it says now is PLS. That's a PL SQL compilation error. PLS, entity package is deprecated. So that's going too far. What you really want to do is say, all right, I want to force those errors 20, 21, and 22 so I can compile my deprecated code. But if anybody tries to use it, oh, and also I can specify a message. And if anybody tries to use it, then they see this. First of all, it's an error, not a warning. So the code will not compile with deprecated code in it, and it will also show me the message. Now, we don't have the ability to right now to specify, well, I guess we do. So this is saying turn on, convert to errors, all warnings across anything compiled in this session. There's no way of limiting the application of those warnings to specific program units in a global way, but I can also say alter package or alter procedure. And in those packages and procedures, set PL SQL warnings to errors. So I might identify that there are 5 or 10 different packages that have certain deprecations in it that I am turning off, they're going away. So I could alter package for those specific objects. And then those would turn into errors, but the others that are using deprecated objects that are not yet actually not to be used, they would not turn into errors. Okay. So as we're coming towards the end of the session, here are a number of aspects that are related to code-based access control. So giving you a lot more control over how to manage access to program units. So in general, you can grant execute in a program unit to a schema or to a role. But now what you can also do is grant roles to program units. So roles are not associated just with schemas, but with program units. So if you're looking at following what is called a least privileged approach, so that any given schema, any given user, any given program unit can only have access to those elements of the code base that you wanted to, then you can fine tune those privileges by adding roles to program units. I'm not going to give a demo on this now. It's fairly complicated to put all together, but these capabilities do exist. In addition, also related to controlling what you have access to, we tied up a loose end in 12.1 for views, and that is with bequeath current user. So hopefully all of you are familiar with auth ID. Let's take a quick look at that. Well, let's just start off with that. Haven't looked at this code in a while, so I'm not sure what it's got in it. Lots and lots of code. Okay, so the auth ID feature was added a long time ago. probably around 9, maybe 10. And what this is saying is the authorization model for resolving references to objects in your code. Auth ID definer is the default. If you don't have it in your code, and most of you probably don't, you're getting auth ID definer. And what that means is that the resolution of any objects referenced in this code, for example, stolen life, is only defined by the definer of the program unit. So when this program unit is compiled, stolen life has to be resolved as a reference inside my database. It's either a table in my schema or a synonym to a table in some other schema that I have access to. So, so compile time dependencies that are not based on a role but are directly granted. And then when somebody runs this code, they don't have to have access to these underlying objects. It's all through the procedure. So if I grant execute on the procedure, I get the privileges of the owner of this procedure. The alternative is current user. So with current user, what this says is when you compile this code, make sure you resolve the reference to stolen life. I still have to have access to a database table of that name. But when I grant execute to you and you run show descriptions, the PL/SQL compiler, the PL/SQL engine at runtime will wake up and say, well, I don't care what stolen life meant to the owner of the program unit. I care about what it means to you, and I actually re-resolve the reference to stolen life or employees or whatever the table is, according to the privileges of the current user. So this means, for example, that I can have one body of code that works differently and points to actually different data structures of the same name in different schemas. Everybody have their own copy of the employees table. And the single procedure will select from employees, but it will mean a different thing and have different data for each different schema using it. So that's the idea behind auth ID. There was a gap, however, in our functionality and support for this, in that if I had a view that called the function, so here's my view, and it calls this function, and the function was auth ID current user, it would not be respected. That current user setting would not be respected because all views were auth ID definer. Now, if you had bequeath current user, I don't know why they didn't say auth ID, but bequeath current user, that will pass the current user setting into the function calls inside that view. So plugging a little hole there. Moving on. Again, more privileges related stuff. So inherit privileges and inherit any privileges. So these are global settings that allow you to manage privileges. And essentially what you can do is override auth ID and bequeath settings so that they cannot inherit privileges from the other schemas. So basically you can say things in effect, all schemas but Scott can use my privileges when running X. And the idea here is to limit the ability to do privilege escalation. You call my procedure, and then you have my privileges. And that might be something we want to avoid for certain schemas. Only certain schemas we trust should be allowed to get that escalated privilege setting from these other programs they're calling. And this way you can actually turn that off. By default, it's turned on. Okay, so it's about 10 minutes before the hour, and it looks like there have been some questions, and I definitely want to leave room for that. So there's more that could be talked about. We've now added support for JSON and PL/SQL via the new predefined JSON types in SQL. The coverage there is not that critical because it's essentially replicating what you're doing in SQL. We're basically taking the SQL functions and pulling them into PL/SQL. There's also what is called a SOTA interface, which allows you to manipulate data structures as if they were documents, like JSON documents, without having any knowledge of the underlying SQL. We added block code coverage so that there's a new package that will actually tell you which code has been covered, which lines have been covered in your testing and executions and which not. Hopefully that will be something we expose to you via SQL Developer APIs and other UIs, in the future. And in addition, though I mentioned this before, DBMS SQL support for PL/SQL types. So as with Execute Immediate, we now support things like binding records and collections and Booleans. You can do the same thing with the DBMS SQL package. I don't know how many of you use DBMS SQL anymore, but we've been keeping up over there as well. Okay, so that is my presentation. I'm going to stop the share. And why don't we go ahead and take a look at any questions people have, and certainly it's a good time to ask new questions. So where do we stand, Patrick?
Well, there's at least one question in the Q&A window. Do you want to read it yourself?
Sure.
Should I
I'll read it? I'll read it for everybody. What the heck? So constantly when we provide enhancements and functions, we must offer maintenance on the older functionalities. Is it predicted by Oracle? For example, when calling a function, you declare it in a file, call it in a query from another file. Now you can declare the function in the same scope from the query. My question is, the previous way to write functions will still work, and you hope that you could expose yourself better. Yes, I realize that English is probably not your first language, and believe me, I appreciate that, and I appreciate the effort made. I'm not quite sure I understand it, so let's see. When we provide enhancements to functions, we have to maintain existing or older functionalities. That's a really important and good point. And so one thought there, and Patrick, just one thing, I'm seeing your name on the screen, I'm not seeing my face. I don't know if maybe everybody is seeing that, but you might want to pin me.
Okay, I'll see your face.
Now I see me. The main thing is I like to see me. What can I say?
Yeah.
After 61 years, I'm still not tired of this face.
Oh.
Okay, enough of that. So as you enhance your code base over years, it is important, of course, to support backward compatibility whenever possible. It's not always possible. And there are some features for doing that. One of the most important ones is adding parameter default values on parameters. So as I add new parameters to an existing function, I want to make sure that all the existing calls to that function stay the same or are still valid. So when I add an in parameter, I can add a default value. And that way any existing calls will take the default value and use it. And it will not upset your current code base. That doesn't work for in-out and out parameters. So if you need to add new out and in-out parameters, then what you want to do is create overloadings. So create a second function or procedure that has the new
like overriding, for example.
Like overriding. It's similar to overriding, yes. So overriding is a topic that comes from object types, from the object-oriented approach.
Mm-hmm.
And that's similar, not quite the same. With overloading, it's basically static polymorphism. And in types, you have dynamic polymorphism, which is the overriding process. So with static polymorphism, I can have multiple program units with the same name, different parameter lists. So you keep that original function parameter list the same, and then you create new ones that have a variety of parameters. And then the key thing is in the package body, you want to go in and refactor your implementation so that there's one core implementation. So for example, if I have a function that takes one in parameter, and then I need to add, let's call it a procedure with one in parameter. Then I'm going to add, I need to pass back 3 values. So I have 3 out parameters or an out record. That's a new procedure with a second out parameter. That should be the core implementation inside my package body. And the previous original implementation that has a single in parameter would call the one with the out parameter, but it would hide the out parameter. It wouldn't return it. So parameters with default values, overloading, overriding if using object types, would be some of the key features there. And I think, is this Elise speaking? So does that answer the question? Is that what you were looking for?
Yeah, exactly this. And just 2 more questions if it's not a trouble. The first one is about performance with these new functions. It's going to probably improve, but there will be problems with compatibilities with the old functions in terms of performance, for example.
So you're saying you have one function that does X, you have a new version of the function that does X plus some other stuff?
Yeah.
And you're concerned that the performance of the original one might get a lot slower. Is that the situation?
Yeah. Yeah, this is the point. Because let's suppose you are in the same database using both functions, the new version and the old one. So my point is, since they will present different performance, I'm sorry, I'm not saying correctly, but so in which way this could affect, my database when running a query or a function or a procedure as well?
So if you have you have a new version of your function, it sounds like what you're saying here is I've got an entirely new version that performs differently. I don't know if it's doing the same thing as before as the other one, but you can't replace the older versions with the newer one. I'm not sure where to go with this question because I'm not sure what would be causing the performance problem. If your older version got slower, or maybe it's just not as fast as the new one, why wouldn't you just use the new one? If it's because you have too many places that you would need to change it, and you can't afford the disruption in your code base, then you would probably just look at incrementally making changes to it. I don't think it's a very satisfactory answer, but I'm not sure I have more to give you right now than that.
No, it gave me a sort of perspective. Thank you.
Okay.
That's it.
You're welcome. Thanks for joining. Okay. Do we have other questions? Any peeks into new PL/SQL functionality in 20C is a question I've got there. To be honest, I've just gotten started, and so I could go to the docs page and show you some. Well, actually, what I will share, there's some of it's really quite exciting. Let's see, Oracle documentation 20C. There's a typo in everything I write. Now you know what me programming is like. So let's see, Oracle database. How do I find the new features? Books, where are all the books? Maybe I won't find it too easily for you. There we go, browse. So this is available to everybody, obviously. So the Oracle Database 20C is available as a preview release only. You can install it via a cloud service. It's not something you can download and install yourself. So keep that in mind. And there's not much more I can say about that right now. And probably the biggest thing in terms of the day-to-day functionality for a developer are extended iterators. And these are pretty wild when you take a look at them. So some of it is just going to be like, wow, I don't know if I'm ever going to use that. But here, let's just zoom down to some examples. No, yeah, multiple iteration controls. So here we go. So in 20C, you'll be able to do things like right inside your in clause, you'll be able to have multiple iterator.
Stephen, you're not sharing your screen.
Oh, I'm so bad. Here it comes. That's right, you didn't see me fumble my way to the documentation. My apologies. So here's the documentation set for the PL/SQL 20C user guide. And the first one up is extended iterators. So basically the idea of iterating through numeric for loops, cursor for loops, collection iteration, vastly expanded. And some of it you're going to say, why did you do that? I can't imagine ever doing that. And some of it you're going to say, oh my God, that's so wonderful, I can't believe it. So for example, come on, did I lose it already? All right. I thought I had an example right here. For loop. Sorry, I'm not being very effective here. Multiple iteration controls. Let's use the table of contents. So with 20C and beyond, you'll be able to have multiple iterator controls right inside the in clause. And lots more variations. Stepped range, so I can do things like, reverse you could always do. You can say by what you want to iterate by, the data type of the thing you're iterating over. So much more flexibility here. But here's my favorite so far. Collection iteration controls. So you want to go through all the elements of a collection? Sure, just go through the values of that collection. Boom, done. So I don't know about you, but this would probably reduce my code volume by about 10% right there. Using dynamic SQL and iteration controls, I haven't even looked at this yet. So look at this. Execute immediate, right inside in values of. So you're going to see much more flexibility, much more orthogonality wherever you could put a statement before you can now put this expression. So lots more controls, lots more to work with. So I think that's a little bit that I can tell you right now. Like I said, I haven't spent a lot of time on 20C, but I think you're going to like it. Okay.
We got one more question.
Yeah.
How's the progress of your revised book, the Big Bible?
Yes. So let's see. You can see the fat book right back there. It's 1,300 pages long. I think the index is 30 or 40 pages by itself. So we have started planning our OPP7, Oracle 7 release. We'll probably cover through 21C is our plan right now. And so we'll be adding some significant content around JSON, both SQL and PL/SQL support for JSON, and polymorphic table functions, qualified expressions, all the stuff you're seeing here. And I would expect to see that in 2021. So I'll be working on it through this year into early next year, and then we'll get it published out. Thanks for asking. But don't wait. Go ahead and order that 6th edition right now. That's perfectly fine. And my plan is also to try to keep the page count to where it is now, because I just feel like a 1,500 page book, that's tough. All right, other questions?
I guess that's it.
Perfect timing, because it's the top of the hour.
Yeah.
Okay.
All right.
Thanks for joining me. Hopefully you enjoyed that. Check out the live SQL scripts for sure. That's where you can get the most value out of what I was just presenting besides the documentation. Check out the examples, play around with them yourself on live SQL, get comfortable with the technology, figure out how to apply it in your own environment, and stay safe and healthy.
Okay, great. Thanks, Stephen. And thanks everyone for joining us this afternoon. Rest me to say that next week we've got Douglas Hood with SQL data caching for performance. So please join. And for now, have a very nice.
He's a great presenter. You'll enjoy that a lot. So do come back.
Okay, great, Steve.
All right.
Okay, thanks again, and have a great evening. Bye-bye.